Hello, today we'll be performing the candy chromatography experiment. This experiment will show the RF values of each dye that was used to color the Skittles. RF values are what scientists use to determine the solubility of pigments. The RF values also help to determine the polarity of the molecules that are in the dye. Polarity is a very important concept in this experiment. Polarity occurs when atoms come together in a chemical bond. These atoms share electrons. When one atom has a stronger hold on the electrons will be drawn closer to that atom. This motion causes a slight charge imbalance. We'll be able to see the polarity in the dye by noticing how far the dye moves on the paper. The one that moves the farthest will have the weakest polarity. To begin our experiment, we will first need to gather our supplies. I'll be using common household supplies so that anyone will be able to recreate this experiment. There are not any safety measures you need to follow, but I will be wearing gloves to avoid any possible staining from the Skittles, but this isn't necessary. My supplies are already laid out in front of me. I have a regular clear drinking glass, a cut piece from a napkin that I have already attached to a pencil by tape. For Skittles, the colors are blue, red, green, and purple, an egg carton, and some toothpicks. To begin this experiment, we are adding water to 4 sections of the egg carton. We will grab a Skittle, drop it into the water. Using a toothpick, we're going to stir the Skittle around until all the dye has come off. The pencil and the paper have already been prepared for us. We attached it with a piece of tape and have marked about 1 inch from the bottom a straight line with 4 dots so that we know where the dye will be placed. We're adding a Skittle. Now I'm using the toothpick to stir it around. The water will slowly change color as the dye comes off the Skittle. We'll just keep turning the Skittle until all the dye has come off. The Skittle will eventually turn white, and then we'll know it's time to take it out. Okay, I'll put it on this napkin. You'll want to be careful not to accidentally put the Skittle into another water, the other waters. Okay. So I've done the same procedure with each one of the Skittles of the different color. This one red, this green, blue, and purple. Now we're going to dip our toothpick into the dye and add it to our napkin. And we'll repeat it for every color with a different toothpick. So now I'm going to put the pencil and the paper into the glass so that the end of the paper is submerged into the saltwater solution, and then we will let it rise. Now that it is finished rising, we can measure the rise of the solvent and the rise of the dye in millimeters. These measurements will go into the formula RF equals distance of compound over distance of solvent. The ORF values can determine the polarity of each color. The higher the ORF value, the lower the polarity will be. You can also judge the polarity by observing the distance the dye traveled on the paper. The dye that has the weakest polarity is the one that travels the furthest on the paper. This is because the molecules are less attracted to the paper. You can also see that the less polar dyes did not travel as far on the paper. This is because the molecules are more attracted to the paper. Or, in other words, it has more polarity.